So, into the topic. Die casting. Die casting is a permanent mold casting process, in which molten metal is injected into mold cavity under high pressure at about 7 to 350 megapascals. The pressure is maintained during solidification, after which the mold is opened and part is removed. The molds in this casting operation are called dies, hence the name die casting. The use of high pressure to force the metal into die cavity is the most notable feature that distinguishes this process from others in the permanent mold category. Die casting machines are designed to hold and accurately close the two mold halves, and keep them closed while the liquid metal is forced into the cavity. There are two main types of die casting machines, depending on how the molten metal is injected into the cavity: hot chamber and cold chamber. In hot chamber machines, the metal is melted in a container attached to the machine, and a piston is used to inject the liquid metal under high pressure into the die. Production rates up to 500 parts per hour are not uncommon. Hot chamber die casting imposes a special hardship on the injection system because most of it is submerged into the molten metal. Hence, the applications are limited to low melting point metals, zinc, tin, and lead, that do not chemically attack plunger and other mechanical components. The figure 1 shows the first step in hot chamber die casting, where with die closed and plunger withdrawn, molten metal flows into the chamber. The figure 2 shows the second step in hot chamber die casting, where the plunger forces metal in chamber to flow into die, maintaining pressure during cooling and solidification. After solidification, plunger is withdrawn, plunger is opened and solidified part is ejected. On the other hand, in cold chamber die casting machines, the molten metal is poured into an unheated chamber from an external melting container, and a piston is used to inject the metal under high pressure into the die cavity at about 14 to 140 megapascals. Compared to hot chamber machines, cycle rates are not usually as fast because of the need to ladle the liquid metal into the chamber from an external source. Still, its high production operation. Typical for casting are the aluminium, copper, zinc and magnesium alloys. The figure 1 shows the first step in cold chamber die casting, where with die closed and ram withdrawn, molten metal is poured into the chamber. The figure 2 shows the second step in cold chamber die casting, where the ram forces metal to flow into die, maintaining pressure during cooling and solidification. After solidification, ram is withdrawn, die is opened and part is ejected. The molds for die casting are usually made of tool steel or mold steel. Tungsten and molybdenum with good refractory qualities are also used. Ejector pins are required to remove the part from the die when it opens. Lubricants must be sprayed into the cavity to prevent sticking. Vent holes built into the mold, since no natural porosity. Advantages of die casting include high production rates, economical for large production quantities, close tolerance and good surface finish. Thin sections down to 0.5 mm are possible. Rapid cooling provides small grain size and good strength to the casting. And the limitations include generally limited to metals of lower melting points, and part geometry must allow removal from die cavity. So, we have studied die casting, which is one of the permanent mold casting processes. Thank you. Here, we come up with new videos on different subjects, to make the academic studies easier for you. So, into the topic. Centrifugal casting refers to several casting methods in which the mold is rotated at high speed so that centrifugal force distributes the molten metal to the outer regions of the die cavity. The group includes true centrifugal casting, semi-centrifugal casting, and centrifuge casting. In true centrifugal casting, molten metal is poured into a rotating mold to produce a tubular part. Parts made by this process include pipes, tubes and rings. In some operations, mold rotation commences after pouring has occurred rather than beforehand. The high-speed rotation results in centrifugal forces that cause the metal to take the shape of the mold cavity. Thus, the outside shape of the casting can be round, octagonal, hexagonal, and so on. However, the inside shape of the casting is perfectly round, due to the radially symmetric forces at work. This figure shows a setup for true centrifugal casting, where the mold rotates about horizontal or vertical axis. Mostly the mold is rotated about horizontal axis and the molten metal introduced from an external source. The centrifugal force acts on the molten metal, which forces it at the outer wall of mold. How fast must the mold be rotated for the process to work successfully? The centrifugal force is defined as F equals to mv square divided by r, where F represents force, expressed in newtons. M represents mass, expressed in kilograms. V represents velocity, expressed in meters per second, and R represents the inside radius of the mold, expressed in meters. The force of gravity is its weight, W, equals to mg, where W is given in kg, and g represents acceleration of gravity, 9.8 meters per square second. The so-called g factor is the ratio of centrifugal force divided by weight. That is, Gf equals to F divided by W equals to mv square divided by r, g equals to v square divided by r, g. Velocity v can be expressed as 2 pi r n divided by 60 equals to pi r n divided by 30, where the constant 60 converts seconds to minutes, so that n represents rotational speed in revolutions per minute. Substituting into the above equation, we obtain Gf equals to pi n divided by 30 whole square into r divided by g. Again, rearranging this to solve for rotational speed n, and using diameter d rather than radius in the resulting equation. N equals to 30 divided by pi into root over 2 g into gf divided by d, where d represents the inside diameter of the mold in meters. If the g factor is too low in centrifugal casting, the liquid metal will not remain forced against the mold wall during the upper half of the circular path but will remain inside the cavity. On an empirical basis, values of Gf equal to 60 to 80 are found to be appropriate for horizontal centrifugal casting. So, we have studied centrifugal casting, which is one of the permanent mold casting processes. Thank you.